Hello everyone. Now we can talk about some other advanced, well, not really advanced, but we're going to talk about some other forms of algebraic equations that you need to deal with. We're going to do a few recap first. In our first introductions to algebraic equations video, we talked about some simple equations such as x plus 3 equal to 6, where you simply get rid of the constant, so that x equal to 3, or you might see something like 3x equal to 12, then you divide by 3 on both sides, then you have x equal to 4. That's what happened. That's what we've been dealing with in our first video. That's what's going on in our intro to algebraic equations. Then when we come to the intermediate algebraic equations, where then we have some combinations of multiplications, divisions, and subtractions, additions, like 2x plus 1 equal to 7, while you have where you can see that there's a multiplications going on here, and then additions over here. So what I've told you guys is to get rid of the plus minus first. Addition subtractions should take priority in this case. So that 2x equal to 6, x equal to 3, because at this point you might see some like two-step or three steps operations in algebraic equations. Things might get a little bit complicated. So one way to know if you get the right answer is that you can check the answers for yourself by evaluating the expressions, the equations with the x of whatever you find. In this case, we find x to be 3, so we applied the equations. We evaluate the equations with 2, just like how we start with 2x, meaning 2 times x will become 2 times 3, plus 1 equal to 7. Well, let's see if that's true. 2 times 3 is what? 6 plus 1 equal to 7, 7 equal to 7. So that is a check. That will mean that your x of 3 is correct. Okay, so now we're going to keep going with some little bit harder problems, because in this case, back in our previous videos, we only see we pretty much see a variable and a constant and equal to a constant, right? But now, what if we involve a little bit more stuff, such that variable, well, plus minus a constant, equal to variable plus minus another constant. So let's see how that will look like. So now let's begin with our first questions of this video. We have 4x plus 6 equal to 8 minus 3x. So that's what I mean by having both variable and constants on both sides. Oops. That was a typo. That is. Now, what should we do first? Again, the principles doesn't change. You should always take care of the addition subtractions first. In this case, I can clearly see that there's a plus 6, so I should minus 6 in this case as a reverse operations. Plus 6 minus 6, that's gone. What's left is 4x equal to 8 minus 6 is 2 minus 3x. I hope at this point everyone followed. And what's next then? Well, I see another subtractions right here. Okay, so if I see addition subtractions at this point, that means I should take care of it. How can I get rid of the minus 3x? Well, you can plus 3x on both sides, of course. whatever you do on one side, you also have to do it on the other side. Minus 3x and plus 3x, that's cancel out with 0. 4x plus 3x is 7x. Seven x equal to 2. What now? What's now? Well, at this point, you only see multiplication. 7 times x equal to 2. So then you have to divide by 7 or multiply by 1 over 7 on both sides, so that you have 1x equal to 2 over 7, which means x equal to 2 over 7. If you want, you can check it by yourself, but it's going to take a while, so I'm not going to do it right here. Okay, number 2. Now, please don't be surprised when you see any constants or coefficients to be either fractions or decimals. 2 over 9x minus 3 equal to 7 over 9x plus 2. Take care of the constants first again, or take care of the addition subtractions. Plus 3 on both sides. So that minus 3 and plus 3 cancel out. What's left on the left side is simply 2 over 9x equal to 7 over 9x. That will be plus 2 plus 3, that is a plus 5 altogether. Now what? What it is that I see a variable here, and a constant here. Remember, in every algebraic equations, the end goal is to reach down to a variable equal to a constant, which is the numbers. So what should I do? I have 2 variables in here. And so what we can do is that we can minus 7 over 9x on both sides. Look again here, 7 over 9x minus 7 over 9x. If you remember, some properties of suppression is that whatever number it is minus its identical numbers always get you 0. So 7 over 9x minus 7 over 9x, that will still cross out to get a 0. On the right side, we can see what's left is a constant of 5. On the left side, I have operations to deal with, which is the 2 over 9x minus 7 over 9x. Well, 2 over 9 minus 7 over 9. 2, well, let's do some check first. Do we have the same denominators? Yes, we do. That means my final answers will also have the same denominator of 9. That's the principles of fractions, addition subtractions. If you forget about it at this point, please review. 2 minus 7, just take it as if I'm doing the integers of 2 minus 7, that will give you negative 5. So altogether, that will give you negative 5 over 9x. Right, let's put it back here, negative 5 over 9x. Now, because my coefficient is a fractions, it is better for me to multiply the coefficients. That will become, to multiply the reciprocal of the coefficients, so that will become 9 over negative 5. Of course, you do it on both sides to keep the rates balanced. You can see that this will cancel out to become 1. Now you have a positive 1x equal to, let's see what's going on the right side of it. You have a 5 and negative 5, that would become negative 1. 9 over negative 1 is negative 9. So x equal to negative 9 altogether. Okay, now we come to question number 3. Where we might see some, we will apply distributions in the question as well. 3 parentheses x plus 2 minus x equal to 11. So what should we do? Well, there's a distributions here, so we should deal with that first. So distributions. Oops. So distribute like that. So the first thing we'll see is that 3 times x gets me 3x, plus 3 times 2 will be 6, minus x equal to 11. Okay, is there anything we can do about it? Take a look distinctively on the right side and the left side. On the left side in itself alone, is there something I can do? Yes, because on the left side I have a variable, constant, and a variable, which means I can combine like terms. Okay, 3x minus x will give me what? 2x. What's left? Plus 6 equal to 11. Okay, now that just get us back to the normal equations that we've seen for a few weeks already. So minus 6 on both sides, 2x equal to 5, x equal to 5 over 2, which means x equal to 2 1/2. Okay. Now let's try question number 4, where both sides will have distributions. Okay, so let's begin. Let's write the equation as it is, 5x, but at this point I should pause because there is a distributive property in here. So negative 2 times x give me negative 2x, and then I have a negative 2 times negative 3, that will give me positive 6. Okay, keep going, equal to another distributive properties where distributions of 6 times x is 6x, 6 times minus 2 is minus 12. Now, is there anything I can combine like terms on either side? Yes. On the left side, I have a variable, constant. On the right side, I have a variable and a constant, which means on the right side, I can't do anything about it. Variable and constant, they cannot be combined like terms, but variable and variable can be combined like terms. 5x minus 2x, that will give me 3x. Copy down the rest, equal to 6x minus 12. Now we just come back to the equations. Looks like equations that we just dealt with in the beginning of this video. So I have a variable, constant, variable, constant. So now let's keep going. I always suggest you guys take care of the constants first. So let's see, minus 6. 3x equal to 6x, well, minus 12, and then minus 6, that will become minus 18. minus 3x, sorry, minus 6x. Minus 6x on both sides, that will be a negative 3x equal to negative 18. The last thing you should do is to divide by negative 3 on both sides. Now negative divided by negative always get you a positive 1. Well, that will become positive 1. X equal to negative 18 divided by 3 is a positive 6, so x equal to 6 altogether. Okay, and let's see. Okay, last question of the day. Sample number 5, where I have 3 parentheses x minus 4 plus 5 equal 5. So again, take care of the additions first. Actually, at this point, it doesn't really matter. You can have two choices. First is to minus 5 here, or you can do the distributions first and then combine like terms. Okay, we'll try to use both strategies, and I'll show you that both will work. All right, 5 minus 5, get rid of it. 5 minus 5 is also 0. So 0 on the right side of the equations. What's left on the left side is the distributions of 3 times x minus 4. So you can do distributions. That will become 3x minus 12 equal to 0, plus 12 on both sides. So you have 3x equal to 12, x equal to 4. Okay, so we reached our answers of x equal to 4. Let's try the other strategy where we apply distributions first. Okay, so here I will copy down the questions again. Plus 5 equal to 5. Now again, I will use distributions first. I will not get rid of the plus 5 in the beginning, so it will be 3x minus 12 plus 5 equal to 5. Now can I combine like terms here? I have a variable, constant, constant, constant. On the left side, I have a repetitive of constant terms, so I can combine like terms. That is a sign that I can combine like terms. Negative 12 plus 5 is a negative 7, so 3x minus 7 equal to 5. Okay, that's just a simple equations that we've been dealing with. Plus 7. Let me rewrite that. Plus 7 on both sides. Minus 7 plus 7, that's 0. 3x equal to 12. We reach down to the same thing. X is still equal to 4, regardless of which approach you try to use. There's actually a few more strategies to solve this particular problem or this particular types of problems, but at this point I'll just show you two just to make sure that it doesn't confuse you more. And that's about it. I hope through this algebra lecture series of lectures you guys learn how to do with algebraic expressions as well as different types of equations, as we've demonstrated in this two or three video lectures. All right, hope you all have a good day. I'll see you guys soon.